This is 1.4, absolute value inequalities. And what we're going to do here is we're going to take ideas from 1.2. So 1.2 was solving absolute value. And we're going to take ideas from 1.3, which was inequalities. And we're going to put these two ideas together. So let's start by talking about 1.2. So in 1.2, we talked about absolute value. And we talked about problems that look like 2 plus the absolute value of x minus 4 equals 8. And we talked about solving this. And in order to do this, we had two steps. First, you had to isolate the absolute value, get the absolute value all by itself. And then the second step you had to do was branch. So those are the steps that we learned about in 1.2. In 1.3, we talked about solving inequalities. And with inequalities, the first thing that we learned was that you could solve them just like an equality. But there was one exception, and that exception was when you multiply or divide by a negative. And when you multiplied or divided by a negative, you had to remember to flip the inequality symbol. So if you were given a problem that had greater than or equal to, when you multiplied by that negative, you switched it to less than or equal to. So now we're going to take these two ideas and we're going to merge them together into a single problem. So let's take a look at this problem. You'll notice that we have an inequality and we have an absolute value. So both those things are present. So let's begin by isolating the absolute value. So we're going to say 3 minus 4 times the absolute value of x plus 1 is less than negative 5. And we're going to get this absolute value by itself. So we're going to subtract 3 from both sides, and then we're going to divide both sides by negative 4. And it's important to notice that when we divided by negative 4, we had to flip that inequality symbol from less than to greater than. Now that we've isolated the absolute value, our next move is to branch, or in other words, to create a positive branch and a negative branch. So on the positive side, we're going to have x plus 1 is greater than 2. And on the negative side, we're going to have x plus 1 is less than negative 2. And now we solve each one of these independent. So subtracting 1 from both sides, we'll get x is greater than 1. This will be our first solution. X is greater than 1, and we'll color that yellow. And for the solution of the negative branch, again, we'll subtract 1 from both sides, and we get x is less than negative 3. So that's our second solution. Now that we have the two solutions, we'll graph each one on our number line. So graphing the first solution, we'll put an open dot at 1 and an arrow going to the right. Graphing the second solution, we'll put an open dot at negative 3 and an arrow going to the left. Now that we have both solutions graphed, we have to make a decision. Is this an AND situation where we're looking for the overlap of these two graphs, or is this an OR situation where you're looking at one solution or the other may be considered? And one thing that we could do is we could pick some test points from the three regions. So basically this is kind of like region 1 right here, this would be region 2, and this would be region 3. And we could grab those test points, we could plug them in, test them and see if they make the inequality true or false, and then graph the region that are solutions. But there is a shortcut to consider. And the shortcut has to do with our original isolation of the absolute value. This guy right here, the absolute value of x plus 1 is greater than 2. And this symbol, the greater than symbol, is the key to determining whether this is an AND or an OR. If your absolute value of whatever it is that you have is greater than a number, if the absolute value is greater than a number, then you're going to be looking at an OR situation. So what this means is that on your number line graph, you're going to have two critical points, solution A and solution B. And the greater than means that you're going to be looking for points that are greater than those values. You're going to be looking for solutions that are outside of or exterior to A and B. On the other hand, if you isolate the absolute value and you have a less than symbol, this is going to be an AND situation. Less than means that instead of the solutions being exterior to the points, they are going to be interior to the points. They are going to be the solutions that are inside because the absolute value is less than some number. And so if it's greater than, it's going to be an OR solution. If it's less than, it's going to be an AND solution. And so try to remember this. And again, if you forget this relationship, you can always pick points and plot them. Pick points in the region, plot them. It takes a long time to do, but it can be done that way. But for our purposes, when we take a look at our original equation, we have the absolute value of x plus 1 is greater than 2. So that means greater than means we are dealing with an OR situation. So this is how we're going to write our answer in interval notation, and I'll write it up here next to the graph. So the blue segment is going to be written as negative infinity to negative 3 with a parenthesis because it's not a closed dot. If it was a closed dot, we'd make this a hard bracket. And then we're going to write the second segment, which is going to go from 1 to positive infinity. So these are the two segments. And to illustrate that this is an or a union of the two, we're going to place a capital U in between the two of them. So this is the way that you join separate segments of solution sets. So the negative infinity to negative 3 is the blue solution set, and the 1 to infinity is the yellow solution set. And in order to put them together, we place a capital U in between them. So this is our solution in interval notation. This is the solution. And if you wanted to check this, you could pick points in either region, plug them into the inequality, and you'll see that it'll make it a true statement. You could also show a counterexample by picking a point that's in the region not shaded by either one, maybe a point like 0, and plugging that in and showing that it makes a false statement. So either way, this is your solution in interval notation. Let's take a look at another problem. So here's another problem, and again, we're going to do the exact same technique. The first move is going to be to isolate that absolute value. So get the absolute value all by itself. So we have 1 minus 7 times the absolute value of x minus 2 greater than or equal to negative 13. So we'll start by subtracting 1 from both sides, and then we'll divide both sides by negative 7, making sure that you flip that inequality symbol because you're dividing by a negative. So now we have our solution, and right away, if you take a look at the inequality symbol, you see that this is a less than or equal to. So that means we're going to be dealing with an AND situation once we get our solutions. So in order to find those solutions, we're going to branch. So our positive branch is going to be x minus 2 is less than or equal to 2. And the negative branch is going to be x minus 2 is greater than or equal to negative 2. And we're going to solve each one of these independently. So now we have our two solutions. The first one is x is less than or equal to 4. And the second one is x is greater than or equal to 0. So now we're going to take these solutions and we're going to graph them on the number line. For the first solution, we have a closed dot at x equals 4. And we're going to shade to the left. So the arrow goes to the left. For the second solution, we have a closed dot at 0 and an arrow going to the right because it's greater than. Notice that we have a region of overlap in between 0 and 4. That's where the green is shaded because yellow and blue make green. And so the yellow arrow starts at 4 and goes to the left. The blue arrow starts at 0 and goes to the right, and there is an overlap. And now we have to determine, is this an AND situation or is it an OR situation? If this happens to be an AND situation, then our solution is going to go from 0 to 4. That is the region of the overlap. If it's an OR situation where it's one or the other, our solution is going to be negative infinity to positive infinity because the whole entirety of the x-axis is covered by both graphs. And once again, we can use the shortcut by taking a look at this symbol. And we know that that is a less than or equal to symbol. So that means if we have a critical point A and a critical point B, we're looking for the region that is in between those two, that is less than these two values. So it's in between the two values. So it looks like our situation, this is the solution. So our solution should be the interval, hard bracket, 0, 4. And if you wanted to, you could always pick points in that interval, plug them into the inequality, and show that they either make it true as you expect or make it false as you expect. So one thing you could do is you could pick this point right here, negative 2, plug it into the inequality, and it should make the inequality false. And if you pick the point 5 and you plugged it into the inequality, it should make the inequality false. The only points that will make the inequality true are those in this region right here. So in summary, for section 1.4, the first thing you have to do is isolate the absolute value and then branch. Once you've done that, then you have to figure out, is it an and situation or is it an or situation? And remember, the and situation is when you have less than, and the or situation is when you have greater than. Once you have this identified, you write your solution in interval notation. And that's all for section 1.4.